Distance off second bearing, practice problem 5. This is the last one with me, and then you have 2 to do on your own. Let's get into it. Distance off, second bearing, practice problem 5. First thing we do is extract all of the information. So the problem reads, you're steaming on a course of 167 degrees true at 19.5 knots. There's information in there. It says our course. Course is equal to 167 degrees true. Gave us a speed. The speed was equal to 19.5 knots. So 19.5, what's a knot? It's a nautical mile per hour. And it continues. At 1837, you observe a lighthouse bearing 224. So it gives us our first time. Time 1 is equal to 18 hours and 37 minutes. 18 hours and 37 minutes. I say it like that so we keep it straight. Bearing 1 is equal to 224 degrees true. 224 degrees true. We keep reading. At 1904, the lighthouse bears 268 degrees true. So it gave us time 2 and bearing 2. Time 2 equals 19 hours and 4 minutes. 19 hours and 4 minutes. Bearing 2 equals 268 degrees true. 268 degrees true. And here's the question. What is your distance off at the second bearing? It wants to know how far are you away from the object on which you took the bearing at this second position. So it wants to know the distance off of the second bearing. What is that? And the way we calculate this is with the table in the bowdage, table 18. Table 18, you're going to need the difference between the course and bearing 1 and the course and bearing 2 to use this table. So let's find those differences. We say the change between course and bearing 1 equals the course minus bearing 1. So what's your course? 167 degrees. 167 degrees minus bearing 1, 224. 224 degrees. What is that? We get our calculator. Right. 167 minus 224 equals negative 57. Don't worry about the negative. We're just worried about the 57 degrees, which is the change between course and bearing 1. Now we're going to do it for bearing 2. The change between the course and bearing 2 equals the course minus bearing 2. The course, 167 degrees, minus bearing 2, 268 degrees. 268, 167, good. So 167 minus 268 equals negative 101. Negative 101 equals the change between the course and bearing 2. Okay. Now we are going to go to our table in bowdage, table 18. Come take a look at this table for me. Okay, so the top row is bearing 1. We're on 57. Here's 56. Here's 58. And we're going to be in the first row on each. So we're somewhere in here. And now we're going down to 101. We slide down the left side and we find 100. We found 100 and 102, but there's no 101. So we have to do an interpolation to get these values. So again, 57, we're going to start at 56 And here's the values right here. It's 1.19, 1.15, and then we slide over here and we're 1.27 and 1.22. We're going to record all of these, add them together, and divide by 4. So let's do that. Let's get our 4 values. 1.19. 1.19 plus 1.15. 1.15 plus, we scoot over to the 58, first column, 1.27. 1.27 plus 1.22. 1.22. Okay. There's our 4 values from the table. Now we're going to interpolate, which means add a piece of information which is not there to this table. We add these all together and divide by 4. Another way of thinking of it is we're going to find the average of all of this. Now, what does that equal? That's going to equal our table value. 1.19 plus 1.15 plus 1.27 plus 1.22 equals, divided by 4 equals 1.2075. We're going to round it 3 decimal places here. So we're saying 1.208. 1.208. That's our table value. To get the distance off second bearing, we times our table value by distance. So our table value is 1.208 times the distance we traveled between taking bearings equals our distance off at the second bearing. We need to find distance. How do we find distance? Distance is equal to speed times time. We can use our little cheat sheet here, our D street diagram, right? Distance is speed times time. Okay, we have a speed, 19.5 knots. What about time? We can calculate change in time because we're given 2. Time 2 minus time 1. So we write it down. Change in time equals time 2 minus time 1. Time 2 equals 19 hours and 4 minutes. Time 2, 19 hours and 4 minutes. We say it like that so we keep it straight. Time 1, 18 hours and 37 minutes. 18 hours and 37 minutes. Okay, we can't take 37 from 4, so we need to borrow 60. So this will turn to an 8. We're going to borrow 60, right? And then we're going to have to kind of borrow again. So this will turn to 50. This will be a 14. 14 minus 7 is 7. 5 minus 3, 5, 4, 3, 2. 27 what? Minutes. So this minutes can't go in here because speed is nautical miles per hour. We have to be in hours. So 27 minutes to hours. We convert that. 27 minutes divided by 60 minutes per 1 hour, right? The minutes cancel, you're left with hours. So 27 divided by 60 equals what? 27 divided by 60 equals 0.45 hours. 0.45 hours. Look at that. Now we're going speed times time. Our speed, 19.5. So distance equals speed times time. Speed is 19.5 nautical miles per hour times time. 0.45 hours. 0.45 hours. Let's get our distance. 19.5 times 0.45 equals 8.775. We're going 3 decimal places. 8.775 nautical miles. That's our distance. And we set up here, table value times distance equals distance off. We're almost there. So 1.208 times distance, which we calculated to 8.775 nautical miles, equals our distance off second bearing. Let's go. 1.208 times 8.775 equals 10.6002. 10.6. 10.6 nautical miles off of the second bearing. That looks good. I feel good about that. Let's check this out. 5, 10.6. Here is 5, and 10.6 is C. Let's check this. Yeah, it checks out. 5 is C. That's the solution to distance off second bearing, practice problem 5. Now you have 2 to do on your own. If you get confused, all of these do the same steps. So just jump back to the previous video or this video, watch the steps, do the steps, and you'll be able to solve these problems.